Okay, this is another attempt. Previous one, the sound didn't work very good. But like I say, these are my first times. There's try to explain this theory, this alternate theory, which should have been accepted, should have been popular. Somebody should have figured it out by now, but for some reason I don't see no evidence of it. But it's so simple. It just involves the way that time slows down around black holes and things. It's not that different when you shine a light into a glass rod. It'll slow down, it'll contract, it'll get bunched up together, and it'll come out. It has to travel a longer distance, even though the distance is the same. It's just the way that time works, but time works on everything. Glass rod will only work on glass, but that's irrelevant. It's the same principle. But originally, the idea started from the Shapiro effect. It was a way that the light curved around around a star. It took longer to arrive than if it was just bent. It's actually the slowing of it down because of the time being slower. But anytime you have gravity, you have slower time. But it's a lot of confusion for most of the physicists. They think, well, falling towards a black hole means that you're traveling relativistic speeds. You're traveling so fast that you contract, but that's not the same thing. It's a completely different thing. When gravity slows time, it's completely different than when traveling. If you could take an object, it could be close to a surface of a neutron star, and it just starts falling. It will be time dilated, even though it's free fall. It's deep into the gravity well, and the gravity itself does the time slowing. That's what results in space expansion. Anytime you create a black hole, when a black hole is in the process of creating, if you could measure from the inside of a black hole, you would see everything exactly like inflation theory. Matter gets farther and farther apart, even though it's because it contracts. It's indistinguishable. The contraction of space is indistinguishable. The contraction of matter is indistinguishable from the expansion of space. If you don't have to expand space, if you contract matter enough, the space expands. It's the same thing. Like, for example, there's a hypothetical experiment. If you were to take two cubes, and you're in a spaceship, and you're falling towards a black hole, even though your spaceship is contracting, the cubes will contract in a way that makes them look like they're moving apart, even though they're not actually moving at all. It's because they're contracting. And the more they contract, the farther apart they appear to be. It's the same way if two blocks of jello side by side, if they dry, they contract. They appear to move away. But when you extrapolate into a black hole, it happens everywhere at once. It's faster than light. It's everything inflation theory. It's the same thing. Only the difference is with the cubes is you have to have a string of black holes so that things don't fall towards a common center where they have to move together. You have to have a string of them, which of course is not very realistic. But if you could, you would find an axis where objects would contract in a way that's indistinguishable from space expansion. Even though the cubes are not moving, they get farther apart because they get smaller. And everything you measure with is also getting smaller. You can't tell the difference. It's expansion of space. That's what it is. And what else was I going to say here before I lose my track? If you, like I say, I'm not even dealing with if you expand space fast enough, matter will split into multiple copies. It's in particle accelerators, you see much the same thing. All these extra particles, if you apply them with enough force, they'll split apart and create antimatter and positive matter. But they'll create it, you can do it, create more matter than what you started with. But I can't explain how it would expand into an entire universe, but I can explain that you will expect there to be more matter created as a result. But then I also illustrate the fact is you take a neutron star and you throw iron into a neutron star. Iron will become crushed. It will be converted into neutrons. If you converted that neutron star instead into a black hole, the space expands so much, such an extreme, that those neutrons will be free-floating. They'll eventually break down and they'll become protons, hydrogen again. Well, the half-life of a neutron is about 12 minutes, so they're not going to last very long outside of confinement of a neutron star. But they break down, they become protons, which is basically hydrogen. It means you can start stars all again. But the thing is, from our universe, we're inside of a black hole, and that black hole, of course, has faster time outside it. Our time is slowed down. That's what causes our space to be created. But for every black hole is another universe, basically. But you could, like I say, you could extrapolate that. But if you can show that matter contracts in a way that's indistinguishable from space expansion, you can prove a theory. It's subject to testable verification. I also often say that our space around our planet has to expand. If you took a measure our Earth on basis of scale, had a grid, everything would fit. But our Earth, because of space expansion, would be larger than would fit the scale measurements. It wouldn't work because space has to expand, the matter has to contract, your measurements all get distorted. But that's what black holes do. That's what space is. Space is increased in zero-point energy. You have more zero-point energy, but I often illustrate the fact that if you removed all the zero-point energy in around an atom, the atom would display infinitely fast time, would become a larger universe. But you can't have zero-point energy. It's always there. It's everywhere. I get into more on that later. But the thing is, I often illustrate how does it mean everything's all connected together that way? Well, if you took a spaceship that could not be slowed down, drag it in an anchor that could not be broken, and it's traveling near the speed of light, and you drag that anchor along the edge of a black hole where the speed of light is 1/2. Anyone that was in orbit around that black hole would see that anchor going 5 times faster than the speed of light, unless it drags an entire black hole, regardless of size and regardless how small the anchor is, because everything's all connected together. It's what Mach's principle was about. Well, if that's the case, the whole black hole would be pulled on, because if it didn't, the astronaut who was in orbit around that black hole would see the anchor going faster than light, which doesn't make sense. I mean, that's a brute force faster than light. I don't see how that could work. But because of it, you also know that in our universe, we can't get any particle to travel faster than light in the same way, basically, because it's attached to the whole universe. There's a quantum vacuum entanglement that's going on to keep everything tied to everything else in this universe. You can't go faster than light, because in our universe, light is regulated, so it's all working together. Well, I have so much more on this, and I'll have to cover it when I get this to work better. And learn what I'm doing, because my sound on my previous one was so bad, and I haven't decided how to delete it yet. So that's going to have to wait. So I'll have to shut this off for now and see if I can't